function, and then we graphed the basic sine wave. Now what we're going to do is we're going to try and do each of these transformations. We're going to start with the horizontal transformations, okay? The stuff that we see right here. Okay? If there was a horizontal reflection, we would do that first. So if there is a horizontal reflection, that B value is negative, the first thing you would do is flip this to the other side of the y-axis. Okay? We don't have that, so then we're going to go through the other transformations. All right, so we're going to you guys can either do new graphs. If you have this, you have all the graphs laid out in front of you for each step. Okay. If you don't, you can do it step by step, or you can do some steps on the same graph. It's up to you. But we're going to go through about 6 steps, so it might get a little bit messy. So we're going to start with our sine function, and we're going to change it to this. Okay. So we're just taking into consideration one of our changes. And what kind of change is this minus pi over 2 going to do to our graph? Okay, it's going to shift it horizontally or vertically? Horizontally, because it's inside the function. Is it going to go to the left pi over 2 or to the right pi over 2? The right. H is actually positive because remember the minus comes in the formula. Okay, so this is an H of positive pi over 2. So we expect to shift to the right pi over 2. So that's what we want to change about our graph. Okay? So I'm going to label our axis again. And you will find, as we start doing more complicated problems, that you may have to change the labels of your axis and put in other marks by like fourths, maybe by thirds or sixths sometimes. Because if this shift was pi over 3, I would want some different markings on my graph to show me where pi over 3 was. Okay? And so we'll work on more of that later. Right now we're just going to get the hang of it, so I tried to put in nice shifting anywhere there was shifting. Okay? So I consider pi over 2 a nice shift because you already have that marked on your graph. Okay? So basically every point is going to move to the right pi over 2. So originally our sine graph started at 0, 0. That point is now here. This is now the starting point of our cycle. Okay? Then it's going to go up. Yeah. Technical difficulties. 0, down, and back to 0. So now it ends the cycle here. What should this be marked as? So I've labeled by pi over 2's. So the question is, what number comes after 2 pi and is pi over 2 more than that? If you struggle with that, think about this with a denominator of 2. 2 pi is the same thing as what pi over 2? 4 pi over 2. So the next one would be 5 pi over 2. Okay. Okay. And so now we could fill in our curve here. Okay. We haven't changed the period at all. It still takes 2 pi to get through it. It just doesn't go from 0 to 2 pi. Instead, we see what we would call our starting point at pi over 2, and then it goes that same amount past 2 pi. Okay? Is this okay with everybody for our horizontal transformation? Same as what we did before, but again, labeling is kind of weird because we have to think about it in terms of radians. Okay? All right, now what we're going to do, yeah, Jordan. You could technically number it in degrees, but it's just kind of like grammar rules in English. Most of the time we label in radians, and that's how you're going to see it the most. So that's what I'm going to stick with. Yeah. Okay. But you have to use degrees or radians because input for the functions is an angle. So the thing is, the numbers here are representing an angle. We could put it in degrees or radians, but radians is just the more commonly used notation there. Yeah. Yeah. So summer is our input is an angle here. That's why the scale here is so weird and not like 1, 2, 3, 4, 5. Yeah. All right. So the next thing we're going to do is the other horizontal change that we had in the equation. What was the other horizontal change in the equation? What's that? Was there a negative with the b value? So look inside the parentheses for sine. I'm not putting it up here for a reason because you guys should have it written down. So it had x minus pi over 2 inside the sine function. What else was in there? There was a 2 before it, right? We factored out that 2. What does that number inside the sine function, so we're talking about this number right here, what does that number do to our graph? A horizontal compression, okay? And so we talked about this being now something that affects the period of the graph, okay? So the period of the graph is how long it takes to cycle through the graph. And we said for the basic sine function, like we saw, it's 2 pi. Okay? But now it's going to be affected by this. And remember, with horizontal stretches and compressions, we always multiply by the reciprocal of this. So we're really multiplying by 1/2, not by 2, which is why we call it a compression and not a stretch. So we're going to take what the period would normally be, multiply it by the reciprocal of whatever this change is right here, and find out what the new period is. So the new period then here, these 2's are going to cancel, and it's going to be pi. That means my graph is going to get through that complete cycle of values in a distance of pi along the x-axis instead of 2 pi. Okay, so think about what that means for our graph. So again, I'm going to go through and label this. I'm going to include the 5 pi over 2 because our graph went there last time. Okay, so yeah, Jay. So yesterday when we were looking at the sine function, it takes 2 pi for the sine function to cycle through the graph. So that's called the period of the function. So for any sine function, you're always going to start with a period of 2 pi, and then you're going to adjust it based on any sort of horizontal stretch or compression. And for future reference, it's going to be the same for cosine because they're really, really similar. But for tangents, it'll be a little bit different. All right, so right now what we have, okay, is we have our graph. I'm just going to make the points, but I'm not going to draw the whole curve. You guys have the curve drawn on the graph previous. We have our graph starting here, following the sequence of points that it normally follows for a sine function, but taking this long takes 2 pi. 1 pi, 2 pi. Okay? What this is telling me is now my period will be pi. That means from the starting point, it's still going to start there. It's still going to follow this pattern, but it's going to be done with the pattern by the time I'm only pi units away. So it's going to complete the whole pattern from beginning to pi units away from the beginning. So in this case, in 2 of those marks that I have marked on my graph, because that's a distance of pi. Okay? So how do I make that happen? I need some marks in between these to make that happen. Right? So now how do I have to scale my graph? Right now it's scaled by halves. So if I need to cut those in half and have even smaller marks between them, I have to scale it by fourths. Okay? So I'm just going to put some marks in between. And each of those marks is going to represent a fourth. Okay? So pi over 4, the pi over 2 that's marked is like 2 pi over 4, and that would reduce to pi over 2. Then this one is 3 pi over 4. That's like 4 pi over 4. This one's like 5 pi over 4. Sorry that mine is messy. That one's like 6 pi over 4. And then it's going to continue. I'm going to stop right there for now because that's going to be enough for me to fit where I know the graph begins and ends. Okay? So now what I'm going to do is I'm going to start at the same beginning I had before. I'm going to cycle through all the 5 values. So I'm going to go like this, up, back, down, back. But I'm going to do that from beginning to end in this period of time right here. Okay? So that's why I needed the marks in between to give me more places, because before I only had 1 mark in between. Right? So look at your cycle of points. Okay? Every sine function looks like this. If you can determine the beginning and the end point, the other point that's at 0 needs to be halfway between them. Okay? So if I know that this is the beginning and this is where it's supposed to end, right here, then the other point where it hits that axis needs to be directly in between them. Okay? Then I need to follow the pattern. Okay? Between the first 2 points is where it hit its maximum, and between the next 2 points is where it hit its minimum. So between these 2, it needs to hit its maximum, and between these 2, it needs to hit the minimum, so that the curve will look like this. Okay? So we took it and we compressed it. Okay? And we made it closer together. All right? So the hardest part, in my experience, but that doesn't mean it's going to be true for everybody, but what a lot of students struggle with is having to rescale the axis when you have to do a compression or a shift of a weird amount or something like that. Okay? All right? So we kept our same starting point. We figured out where our ending point was based on how the period was adjusted. Once we had the beginning and the end point, we just thought about how to follow this pattern of points in between, okay, and made that happen. In this case, we had to add some marks in between, some quarters, okay? Is this all right with everybody? So stretching and compressing the period. All right, so that's all the stuff that happens horizontally to our function. So we shifted it. That's why the beginning point is here instead of here, okay? And then we compressed it, which is why the wave happens so quickly instead of stretched out over the same amount of time that it normally is. Now for what's happening outside of the sine function. So anything that's multiplying in front of the sine function or being added or subtracted onto the end of the sine function. Okay, so look back at the equation that we wrote down. Okay. So you should see that we have a -2 multiplying in front of the sine function. Okay? So I'm going to rescale my graph so it's the same. You can spend some time doing the same thing. I'm writing the numbers lower so I can plot the points and they don't get in the way. But it's just messy. 3 pi over 4 pi. 5 pi over 4. Okay. I think most of it happened there, right? What was our beginning point of our graph? The last step that we graphed, where did our graph start? Which mark on the axis? At 0? No. Originally it started at 0, but our last graph that we just finished, at pi over 2. So it started here, right? And then it went up. You guys already have this on yours, but mine's just kind of missing. Like that. I'm just going to keep the points there, but not draw on the curve, and then make the adjustments I need to make. By there being a -2 in front right here, what adjustments are going to have to be made? Okay, so there's a reflection, which means anything that was above that middle axis is going to end up below. So like how it started with the top wave, and then the lower wave came second, those are going to flip. Okay? What else is going to happen because of this number? A vertical stretch by 2. That means from wherever like the middle is, instead of your wave reaching a maximum at 1, it's going to reach a maximum at 2, and its minimum, instead of being at -1, is going to be at -2. Like you saw in the investigation when we put the 3's in front of the functions, that the hills and valleys just got a lot higher and lower. Okay? But these points kind of stayed in the same place. So what we're going to do is we're going to flip it over, okay, or vertically reflect the point so that maximums become minimums and minimums become maximums. And instead of it reaching highs and lows of 1 and -1, we want to adjust it so it reaches highs and lows of 2 and -2 because of the stretch. Okay? So I'm going to mark the 2 and -2 on my graph. This means that none of the 0 points are affected, right? Because if we're reflecting, they don't get reflected because they're on the axis. And if we're stretching the maximums and minimums, they don't get stretched because they're on the axis. They're at 0. So these 0 points that we had, they're all going to stay the same. All right. Now, right here, we had a maximum at 1. So if we make these 2 changes, 1, it's going to flip over, or we're going to reflect it so that it's going to become a minimum instead of a maximum. And then secondly, instead of reaching 1 unit away from the axis, it's going to reach 1 times 2, or 2 units away from the axis. So this is going to get flipped and stretched to -2. And the same thing can be said about the other point that represented a minimum. It's going to get flipped, so it would be up here. Then it's going to get stretched to 2. So that our wave now goes like this. Okay, so same amount of space the wave happened, but now it has a minimum where there was a maximum, and the maximums and minimums reach further away from the axis because of the stretching part of it. Okay? Is this all right? Questions? All right. So what's the last thing we have to do to our function? All that can be left is a k at the end. Did the function have a k at the end? Yeah. Well, Good. So we just shift the whole thing up 1. And that means instead of these points being at 0 here that were kind of like our axis that we were basing everything off, that's going to happen at 1. Okay? Which means the maximum is going to be up at 3, and the minimum is going to be at -1 because we're going to just shifted everything up 1. So I'm going to scale my axis again by 4. I wrote the numbers across there so you can see, but obviously they're not lined up that nice. All right, so remember our 0 started here at pi over 2, but now it's not at 0 anymore. Everything's getting shifted up 1, so that's going to be at 1. So all my 0 points are going to be across here now instead of across here at 0. Okay? So my other 0 point was right here, and my last 0 point was right here. Why? Because of this part of the equation right here. Is that all right? So every time we just add or subtract something on the end, we just shift up or down. Is that okay? Then in between these 2 points, because of our reflection and everything, there was a minimum, okay, and it was 2 below the axis. But now the axis is here, so 1 unit, 2 units below is going to be down here. And between these 2 points, because of the reflection and everything, was our maximum, 2 units above the axis. So it used to be here, but we got shifted up 1, so now it's up here. So it's the same wave you drew the time before, except for now it appears that the axis is like right there. It's basically, that's the shift that happened. Okay? Now this is the graph of 1 period of the function. Normally, they want more than 1 period, but when you do all the changes, you should do them to just 1 period. Then if you need to graph more of the function, you just copy your pattern of points, right? So this is the beginning, this is the end, and then it starts over again from the beginning. So if I wanted to continue this pattern and show people what the graph looked like in both directions, I just know it goes 0, down to, back to that, up to, back to that. So here, and then it would go down to, back to here, up to, back to here, up to, back to here, and it would just follow the same pattern. Okay? And then you can extend it in both directions. So in this direction, I could do it the other way. Like, it just hit a minimum, then it would have to hit a maximum the next time that it was through. So it would go up here, and come back down here, and I could keep continuing it that way also. So our goal is just to graph one section of it, and then if we want to see the graph extended out, just follow the pattern of the points and keep extending it out. Don't try to graph a bunch of it and then make the changes. Make all the changes on just one cycle or one period of the graph. Okay? All right. So I want to go back through